Is it on?
Yeah, it's on.
Okay, cool. So let's explain the use of the HPLC.
Yeah.
So we start out with all the components. We
Yeah.
have a photodiode array detector, you have
Yeah.
a column oven, we have
Yeah.
2 pumps,
Yeah.
we have an inline degasser which is associated with this pump here, which is pump A,
Yeah.
and then we have the CBM, which is the central processing unit that
Unit.
connects all these pieces to the computer itself. So when you turn on this instrument, the first thing you want to do is turn on all of the quote-unquote dumb things,
Okay.
which includes the photodiode array detector, the column oven, and the 2 pumps.
Yeah.
So we'll turn these on by pressing and holding this button here on the left,
Yeah.
left corner for each one, and that will turn them on. Then what you want to do is switch into the solvent that you're going to be using for your runs, and to do that, you will swap the leads from whatever solvent reservoir they're currently in, which is probably the storage bottles in the back,
Yeah.
and you will put them into the appropriate solvents,
Yeah.
and then you will take these 2 dials here on the left and turn them 90 degrees, like that, and that will open the pumps up directly to waste.
Yeah.
If you press the button here, purge, third one down,
Yeah.
then what that will do is clear all the solvent that's currently in those pumps, and it will fill the pumps with the solvent you just put the leads into.
Yeah.
Okay, so now you fill your pumps. That takes about 5 minutes to do. You
Yeah.
need to make sure that you're back here after 5 minutes to stop that process by turning these back
Yeah.
to the
Okay.
upright position. Okay, so the next thing you want to do is turn on the smart component, which is the CBM.
Mm-hmm.
And after you turn that on, then you're ready to engage the computer. So in order to gauge the computer, we use the software called LC Solution. So we could open this up and it would bring us to this menu here.
Mm-hmm.
And importantly, we note that this thing can run multiple systems at the same time, but we only have one. So that's the one in the far left corner called
Collagen.
Collagen.
Yeah.
So we click on that and it'll open up our user interface from which we do all our manipulations.
Yeah.
So presumably we would want to next equilibrate a column of some kind, but we need to do everything through methods. We need to make a method file for everything.
Yeah.
In my case, I've already done an equilibration of my column, so I think the most appropriate thing to do would be to show all of this through an injection. So the
Okay.
first thing, I want to run a sample, and my sample is going to be a peptide.
Yeah.
And I'm going to use a method that I've already designed, but I would show you how to access that. So if you're going to use a method that's already in existence, you will press File and then Open Method File, and then you'll find your method in the directory. In my case, it's somewhere in here. And since I don't know anything about this peptide yet, I'm going to use Test Analytical, and that's the method that I've chosen. And then you can see all the settings here. What you see here is 3 windows, and this top one in yellow shows you what's happening with the actual LC part.
Yeah.
The one in the middle shows you what the PDA is detecting, and the one down low is showing you an actual absorption spectrum of whatever is coming through the PDA, which is pretty nice to see real time. If you go down below, you can see all of the parameters associated with what's going on with the HPLC. And I like to use advanced here in instrument parameters because there's a lot more you can select and play with. The first thing we probably want to do is look at pumps. Now pumps shows you the defaults or what's happening with the method. In my case, I have a total flow of 0.4 mils a minute, that flow is split between pumps A and pump B, which you will then direct later when you tell the instrument how to operate. But I'm also using right now a B concentration of 10%, meaning I'm flowing 90% from pump A and 10% from pump B. So mine currently right now is flowing 10% acetonitrile in water with 0.1% TFA.
I see.
Okay, so now I want to tell this thing how to run a method. So we go to the LC time program, which specifies what the HPLC is actually going to do during a run. And we go down here towards the to set up what's going to happen at each time.
It's time, okay, yeah.
So the first thing the initial time is, so each time is the final time associated with a time period.
I see.
So when you see time is 3, this means from time 0, the point at which the method starts running, to time 3. And then the module means whatever we're part of the instrument we want to make a modification to. Importantly, we can make a modification to the oven, which is where the columns are here, or the controller.
I see.
So what I want to do is I want to tell it from 0 to 3 minutes to just run at 10% B. So all I do is keep the value at 10%.
Okay.
This is the same value as the defaults for my method, so nothing should happen in the beginning. Now I wanted to run a 20-minute gradient up to 90% B, so I can see where my peptide comes off, and generally it's going to come off before 90% in most cases.
Yeah.
So I say up to 23, make the pump B concentration equal to 90%, and that will run a gradient from 10 to 90 over 20 minutes. Then I want it to hold 90 for a wash for 10 minutes, so I put in 33 and 90. I wanted to bring it back down to re-equilibrate, so I bring it over 2 minutes, back down to 10, and then I do a 15-minute re-equilibration at 10. And then I want the method to stop.
Yeah.
And this isn't a stoppage of flow, this is just a stoppage of data collection, so I say controller stop, which is right here. Okay? Now if I want to actually see what's going to happen, I say draw curve, and you can see that this is what's going to happen.
Okay.
We're going to have a little flat, we'll run a gradient, we'll do a wash, we'll bring it back down and re-equilibrate. Sound good?
Yeah.
Okay. Under data acquisition, we need to make sure that the times agree with what's happening in our time program.
Yeah.
So the LC stop time is always going to be the time that you tell this thing to stop in the LC time program. So we set at 50, thus it changes this value here. But we can change. We have to independently change the time associated with the detector. So down here, this is the end time for detection by the PDA. And if I was to tell this to stop at 40, then it would stop at 40, but the LC would keep running and collecting data.
So your table containing only 40 minutes then?
Right, exactly. A lot of these other things I do not play with because they're defaults that have been set and work just fine. In terms of the PDA menu, I don't really change anything because this is all set very well, and it's basically set to collect all data associated that the lamp can detect.
So don't touch.
I would say don't touch, right? Okay, in the column oven, there's a couple important things. We can set the temperatures that we want to run at, as well as a maximum temperature, which would be an alarm type function. I usually run at 40 degrees C, which I think works pretty well. And then the maximum temperature that I have set is 85. I've never had a problem with a temperature alarm anyway. Now, the other very, very important thing is this system is built to run either analytical or prep.
Okay.
So if you want to run analytical, you need to take this thing here called the valve setting, and you need to turn that to 0. And if you turn it to 1, that's the prep.
Right.
Okay?
That's important, yeah.
That's very important, because you don't want to do a prep run on an analytical setup or an analytical on a prep, because then you'll have blowouts from high pressures or low pressures. Okay, so now we're set up to run analytical, and at this point I don't really have any interest in collecting fractions, but I have the option to, when we do a prep run, we can put that in. In terms of the controller menu, the only thing I ever have selected is power on. I'm sure there's other ways to program these events, but I have not needed them as of yet. So now we're ready. So I've done all these things to the method, and I want to tell the computer what's going on, so I need to say download. And that takes all this information that's in the computer, sends it through the CBM to all the other components associated with the HPLC.
It's transferring the information.
Right. So it's transfer the information, and you can see it responds because now all the settings have changed that are over here on the right. And this tells you we're running at 0.4 mils a minute, which is fine. And then we have a B concentration of 10. We have pressures that are generally acceptable, so we should be okay. So now, importantly, prior to us getting here, a lot of this was already on. So what I'll show you is that in order to control flow as well as the column oven and the PDA, you can go to these settings, or these buttons right here.
Yeah.
So to turn on the PDA, you hit this guy. That should turn on the lamp, which will happen in a second. Hopefully. Okay, that'll happen. And then I'm going to turn on the column oven, and that'll make sure that the temperature is set. And then we turn on the pump, and then we get flow. Okay?
Yeah.
Okay, now, importantly, you've seen that the PDA was engaged, so the lamp is now on.
So
Okay.
this machine is ready to...
This machine is essentially ready to go.
I
So let's
see.
do a run. Okay. And we go to acquisition, single run.
Yeah.
And then I don't change a lot of these things because I generally put all the information in the actual name of my file. So I'm going to just change that right here, and I'm going to put test 1, and I'm going to say 10 to 90, 20 min, and my injection volume is going to be 5 microliters. How's that?
So it's all...
That's all I do,
You're
10.
naming your...
I'm just naming my sample.
Okay. Yeah.
Test 1 means it's the first injection I'm doing. I should put 10 to 90 means the gradient that I'm doing,
Yeah.
which you can name these however you want. This is how I do it. 10 to 90 is the gradient. and then over 20 minutes is the time over which the gradient is happening, and then a 10 microliters injection volume. Now, if I press OK, this thing is essentially going to be ready to go.
I see.
Now we want to do an injection
Of course, in a
In
0,
order-
not in 1.
into 0, yes, which is the analytical side as opposed to 1.
Yeah.
Now, in order to do an injection, we're doing things manually, so we need to manually load the loop with sample.
Yeah.
So basically, if we were to open this up, I'll show you there's two loops. There's a really big loop right here, you can see in there. That's the preparative loop.
I see.
And there's a little loop right back here, which is 20 microliters, which is the analytical loop.
Yeah.
And we want to load the analytical loop. Now, in order to do that, you have two settings associated with this, which is the injection port. You either have the down one, which means that it's literally flowing through the loop right now, which is the normal setting that you want to leave this on all the time. If you want to load the loop with something to do an injection, you lift this up.
Load. Okay.
Okay. Now, the loop is exposed to this outdoor port, so we can actually make an injection into it.
Yeah.
Okay. So I don't really know what people have been injecting here, so I think it's actually probably a good idea to clean this out first.
I think Chella told me that he washed it.
He washed the analytical?
I think he was using analytical only.
I think he was using...
Right?
I don't know what he was using.
But well, I mean, just to make sure you can wash it, yeah.
Right. So, yeah, just to make sure everything's peachy, we'll wash it. And I'm just... This is a 20 microliter loop, so this is extreme. This is like excess
I see.
by far. But I'm going to take the 1 ml syringe here.
Yeah.
And I've basically just taken a peptide sample and I've dissolved it in 10% acetonitrile water. Really fine. And I'm just going to take some of that 10% acetonitrile. And we're just going to send a little bit through this loop here. All you're going to do is throw this into that little hole you see right there. And then you flow, you should see backflow come out of the loop.
Coming out,
And
yeah.
see, that was a good idea because someone's been injecting some purple crap.
I see.
So I'm actually going to do that again.
Yeah.
So importantly, that would have ended up
In your,
in my stuff.
you see some more pigs than.
Right, and I don't want to see those peaks. Those people should clean out their stuff. So I'm going to do that again with a full... Alright, now, for my purposes, that should probably be fine. We are running a separatory method anyway.
I see.
So, that should work. Get this guy back. I don't know who's been running pig stuff, but let's make it happen. Alright, now, I only want to inject a little bit, so I'm going to use the small syringe here. It's a good new syringe. Someone just bought this. I'm going to treat it very nicely. Oh, it works wonderfully. That's beautiful. Alright, I filled that up with 5 microliters. Okay. Looks pretty clean on the tip. So, I will thread that in, and I will make the injection. That means the loop is now filled. Very simple. But we're not flowing through the system yet.
Yeah, okay.
So in order to make this happen, all we have to do is bring this down to the downward position, and then flow will start happening through the loop into the column. So what I'll do, normally we can set these leads up so this happens electronically, but I haven't been doing lately because I don't feel like it.
Yeah.
And it's pretty simple for me to just push this down, push this guy down, and push start at the same time. That's what I'm going to do. 1, 2, 3, down, start.
Cool.
And now the method runs. The
For
method's going to run for about 50 minutes,
Okay.
and then after 50 minutes we'll come back and see what happens.
Perfect.
And you can see that the LC and PDA have gone to running, which is in blue, meaning that the method itself is actually running.
Perfect.
Everything sound good?